Have you ever wondered how your phone just knows how to finish your sentences? Or how a chatbot online seems to get exactly what you're asking? Well, today we're going to pull back the curtain on all of that. We're diving into the pretty wild world of natural language processing, or NLP, and figuring out the incredible challenge of teaching computers our most human skill, language. So let's just start with a little puzzle. Look at this sentence. I'm heading to the bank. For you and me, that's totally simple, right? But for a computer, a machine that's built on pure, cold, hard logic, this sentence is an absolute nightmare. Any guesses why?
Yeah, it's because the computer has no clue if we're talking about going fishing down by the river or going to deposit a check. The word bank means two completely different things, and without any other context, the machine is just stuck. And this one little example, it really shows us the single biggest problem in all of NLP. And that problem has a name: the ambiguity problem. This is, at its core, why teaching our messy, beautiful language to a machine is so incredibly difficult. You know, there's a technical term for this: inherent ambiguity. And for us humans, language being ambiguous is a feature, not a bug. We use context to figure things out without even thinking about it. But if you're a computer and you need crystal clear one-to-one instructions, this is a massive, massive hurdle to get over. And look, it's not just single words like bank. This problem pops up everywhere. It can be in the grammar, it can be in the way a sentence is put together, and then you get into things like sarcasm, irony, and humor. I mean, that's a whole other level of difficulty for a machine to even begin to understand. Okay, so how on earth did we start to solve this giant, messy problem? Well, the first big step forward came from a pretty simple idea, actually. What if we could just teach a machine to predict the next word in a sentence? This simple idea, it turned out to be the foundational building block for everything that followed. And the tool that does this is called a language model. The easiest way to think about it is like a really, really powerful version of the autocomplete on your phone. Its main job is to look at a string of words and just calculate the odds of what the very next word is probably going to be. And the whole idea behind this is summed up perfectly by this old quote from a linguist named J.R. Firth. You shall know a word by the company it keeps, right? The words around a word give you all the clues you need. If you see words like river, water, and fishing, you're almost certainly not talking about a financial bank. It's all about the context. So, what this looks like in practice is a language model sees a phrase like the cat sat on the, and because it's analyzed billions of sentences from the internet, it calculates a super high probability that the next word is going to be Matt. And at the same time, a crazy low probability for something that makes no sense, like galaxy. Now, trying to analyze every single word that came before in a long document would be, well, it would be computationally insane. Your computer would just melt. So engineers came up with this clever little shortcut called the Markov assumption. Basically, instead of looking at the whole history, the model just looks at a small window of the last few words. Sure, you lose a little bit of the long-range context, but you gain a ton of speed, and it's what makes this whole thing actually possible to compute. Okay, so predicting words is cool. It's a great party trick. But what can you really do with that? Well, this is where we get into some seriously powerful, real-world uses, like automatically sorting huge mountains of text by what they're about. This is a job called text classification, and honestly, it's kind of like a digital sorting hat for all your data. It can look at an email and, poof, decide if it's spam. It can read a product review and figure out if it's positive or negative. Or it can sift through thousands of articles and put them into the right buckets: sports, technology, politics, you name it. Now, when it comes to learning this stuff, a machine basically has two ways to go about it. First is supervised learning. This is where you basically give it an answer key. You feed it thousands of emails that you've already marked as spam or not spam, and it learns from your examples. The other way is unsupervised learning. And here, there is no answer key. You just dump a giant pile of text in front of it and say, go figure it out, find the patterns yourself. That second approach, the unsupervised one, leads to this really amazing technique called topic modeling. The machine just chews through a huge collection of documents and automatically starts grouping them together based on these hidden themes it discovers. It doesn't know the word astronomy, but it figures out that all the documents with words like galaxy, planet, and star probably belong in the same pile. It's pretty incredible. But we can push this even further. We can go beyond just figuring out what a text is about to understanding something much, much more human: emotion. So the big question is, can a computer actually learn to detect feelings?
And this is the whole goal behind something called sentiment analysis. At its most basic level, it's about reading a chunk of text and figuring out if the vibe is positive, negative, or just neutral. And this is absolutely huge for businesses trying to understand product reviews or for anyone trying to gauge public opinion on social media. So the simple version is pretty straightforward, right? The model learns that words like loved, amazing, and fantastic are positive. Words like terrible, awful, and hate are negative. And neutral statements are just the facts, no real emotion tied to them. But as we all know, human emotion is way more complicated than just good, bad, or neutral. So to really level up, data scientists use models like Plutchik's wheel of emotions here. This helps teach computers all the nuances and the connections between different feelings, things like joy, trust, surprise, anger, and sadness. So think about the journey we've been on. We went from the basic problem of a single ambiguous word to predicting text, to sorting topics, and even trying to understand emotion. So what's the next big frontier? Well, the biggest change has really been in how these machines learn in the first place. This picture really says it all. The old way, what we call classical NLP, meant that scientists had to spend countless hours handcrafting all the rules. They had to manually tell the machine every little rule of grammar and what word patterns to look for. But the new way, deep learning, lets the machine figure all that out for itself just by reading massive amounts of text. The AI pioneer Andrew Ng really nailed the old way when he said, applied machine learning is basically feature engineering. And what he meant was that so much of the work was this tedious manual labor of picking out the right features for the machine to pay attention to. It was a huge, slow bottleneck. Deep learning completely changed the game. Because it gets rid of most of that manual work, it allows these models to learn the important patterns all on their own, directly from the raw text. And that shift is what unlocked the mind-blowing abilities we're seeing today in the big models that are all over the news. So that leaves us with a pretty big question. If machines have gone from needing us to tell them every single rule to now being able to learn the incredibly complex patterns of language all by themselves, what's the next great communication barrier you think they're going to break? Let me know what you think. Thanks for tuning in.